All right, the next area of geometry we're going to look at is area. So area, when you're talking, we just finished up perimeter, which would be like fencing around your house, around a pool, around a, to keep a dog, a fenced-in yard, to keep a dog inside or a pet. When we talk about area, now we're talking about putting carpet down, painting a wall, anything that's covering that two-dimensional surface. Oops. So we have several formulas that go along with this. Looking at this, all right, for number one, we have a square. How do I know it's a square? Well, because that 10 on top jumps to the bottom. Sorry, I didn't mean to highlight. And the one on the right jumps to the left. So I have this figure that has 10 on all sides. Now, my area for any rectangle or square really is length times width. But specific to a square, it is S squared, which means the side they give you, 10 squared. So really this is 10 squared or 10 times 10, which gives me 100. Notice how I write this A equals down every time. I don't drop it. I don't lose it. This is the first thing that we've done with a variable that sticks throughout, and it's important to keep it throughout as well. Now, my unit is inches, and I actually want that squared because I've taken one dimension and I've multiplied it by another dimension, so I get the dimension squared. I get the units squared. If you wanted to do it the other way, you could just do length times width, and that would be the length 10 that they gave you times the width 10 that they gave you, and that is also 100 inches squared. So again, either formula you use for any of these will provide you with the same answer, granted that you follow all the mathematical rules you're supposed to. All right, so number 2 is a triangle, but it's kind of an odd one straight off the bat, because for a triangle, we need 1/2 times the base times the height. Well, for this one, the height is on the outside. The height, you can't look at a diagonal line. You have to look at the line that's perpendicular to the base. Perpendicular means that they meet at a right angle. So the base and the height have to meet at something that looks like that. No diagonals in there. So if I look at this, my base is 4. My height is 9. I'm going to plug that in, and I get A equals 1/2 times 4 times 9. Now, when you're taking a half, you don't want to take a half of each of those. You only want to take a half of one of them. So I could just at this point put this in my, calculator, or change my 1/2 to a decimal by doing 1 divided by 2. Or I could say this: 1/2 of 4 is 2, and then I multiply it by 9. So I get 18 centimeters, and again, I'm squared because I'm working on area. Okay, now a parallelogram, which I also have to put on there, falls under the same rules as rectangles. So my formula is base times the height. So similar to a triangle, but without that 1/2. So my base is 29. My height is 10. I'm going to plug that in. A equals 29 times 10. Notice I keep dragging that A equals down, and I get A equals 290 yards squared. All right, number 4, I have a circle. Now, notice, unlike the perimeter, or the circumference as they call it, of a circle, you cannot use the diameter for area. Okay, you must use the radius. So given that you must use the radius, like on this one, you have to find the radius, because if the diameter is 16, in order to get to the radius, we need to do 16 divided by 2. We need to cut it in half. So the radius for this one is 8. Okay? If I were to look at any point from that middle out to the side, it would be 8, because in order to get all the way through to the other side, you would have to double it to get 16. So my formula is area equals pi times r squared. So when I plug that in, remember pi is just a number and r is 8, and I'm squaring that. Now, order of operations tells me I have to do exponents first, so really that's pi times 8 times 8, because 8 squared is 8 times 8, which gives me a equals 64 pi. Remember, we can always throw the number in front of the pi. We are totally okay with that answer. If you have to or want to get a decimal, you can do 64 times 3.14. And we get a equals, sorry about that, 200.96. Now, again, rounding to the nearest tenth. That is going to make this 6, round the 9 up, but when the 9 rounds up, we have to bump it to this 0. So we get that the area is 201.0. So 64 pi or 201.0. And all right, here's my other one that I need to give you the formula for and write it on that reference sheet. For a trapezoid, I have the area is 1/2 the height times base 1 plus base 2. Okay, and the bases are the parallel line segments, okay? Or the parallel pair. So when we look at this, our bases are going to be 6 and 4, because those are parallel to one another. That means they'll never intersect. If you think about like, the northbound and the southbound lanes of traffic, they're never going to mix and match. Okay, then there would be a collision. So 6 and 4 are my bases, and then 3 is my height, because that is how tall it is. So we are going to now plug it in. So A equals 1/2 times the height 3 times 4 plus 6. Now, I don't really want to take 1/2 of 3 because it's an odd number. So let's do a little work here. I'm going to do my parentheses, 1/2 times 3 times, and then 4 plus 6 is 10. So now, like I've said before, you can do multiplication in any order. So 1/2 times 10, or 1/2 of 10, is 5, and then I'm multiplying 5 by 3. So I get 15, and now I'm working in centimeters squared. All right, so we have now a parallelogram, so we're going to draw this. Parallelogram is kind of a rectangle, but almost like it's falling over, Leaning Tower of Pisa style. We have a base of 5 and a height of 2. The height we usually put on the inside with a dotted line. The other place you can see it is just like in number 2, where you draw those dotted lines out outside of the picture, and you do it there. So we have this. We know that the area of a parallelogram is base times height. My base is 5, my height is 2. That gives me an area of 10, and we are in feet squared. All right, number 7 is a trapezoid. I'm going to draw it just like our trapezoid above. And I'm going to put that dotted line in for height. I know that the bases are 3 and 8.5. Oops, and I did that backwards. Really, I should have had the 3 on top and 8.5 on the bottom, just for my brain. and a height of 12. So you see my picture is not at all drawn to scale. It does not look like that 12 is bigger than the 8.5, but again, it's okay because you assume that figures are not drawn to scale. So I have area equals 1/2 times the base, times the height, times base 1 plus base 2. I plug all that in, and I get 1/2 times 12 times 3 plus 8.5. So I'm going to add that. I'm going to get A equals 1/2 times 12 times 11.5. I can do 1/2 of 12. I know 1/2 of 12 is 6, and I'm going to multiply it by the 11.5. 11.5 times 6 is 69. So my area is 69 inches squared, and I'm all done. All right, my last one, I have a square. So again, when I draw a square, I put those tick marks in, and I have a side length of 12. I'm only going to write it on the one, but I could write it all the way around because it's a square, you have all 4 equal sides. So my area is S squared, so that is 12 squared, which is 12 times 12, which is 144. I'm in centimeters squared because area is always squared, and the unit they gave me in this one was centimeters. If you have any questions, make sure to bring them up, and we will go over them at our live. If we look at them, this is going to be this second column. So again, area is talking about a two-dimensional shape, so you'll only see it for square, rectangle, triangle, and circle. Notice that they're all called area. There's no one that's different than the other, like a fancy name like circumference. They're just the area. You have different formulas, and I think actually while I'm thinking about it, I think you will also need trapezoid too, so I'll make sure to put that one on there. All right, so